To what extent is a theory of everything a difficult thing to have in science due to the nature of constant questioning and discoveries in science? It's a question from Quora.com, specifically Graham C. Lindsay. He has asked this question several times. Let us make a video. Now, to answer this question, we must ask, it can only be answered in two parts. How does everything work? Why are things are as they are? And what is it? What is this everything we want to know works? Incidentally, it is the constant questioning and discoveries in science that lead us to understand how everything works. So we start off with what is it, and I will run quickly through it. What is it that when we say everything, a theory of everything, what is everything? Well, everything is information. Understand, it's information. Magnetism organizes into a wave. It's told us that it organizes into a wave because we've asked it the question. It has informed us. Why does it organize into a wave? Well, it is telling us there's something underneath. Understand? It is informing us there's something finer than basic particles. See, we ask questions and we didn't know this information. It wasn't knowledge that there's something finer than basic particles. That's why magnetism organizes into a wave. Is the most efficient way to travel. We didn't know this. We had to ask the question. And then now we know it is now part of the human knowledge base. Everything has all the same basic characteristics. All information is discrete, it can be isolated, is consistent, it is independent, it is in a relationship, it can be used to count, it can tell the time, and it can measure. Now, how does it all work? Why are things as they are? So from those basic characteristics, let's look at relationships. Now, the first law of information is everything is in a random relationship, and all relationships cost energy to maintain. In 2016, I wrote this paper. You can take a screenshot if you like. I'll read it to you. It's called A Treatise on Information, Knowledge, Economics, and Technology by Bhekuzulu Khumalo. Now, so let's understand, this is a basic energy of an elementary particle. This is its energy that keeps it together, and this is the free energy. It's moving. So it has energy that gives it structure, and then there's free energy that keeps it moving. Then this is a two-system solution. It can be two particles, any two systems. So they give away free energy, so that they become. And then we get here to equation one. What is free energy? Free energy is what allows things to be in relationship. Equation free energy of a system will be free energy plus free energy of 1 and J minus the new B. You understand? So, well, you can read the paper yourself, and then you get, this is pretty important. This last line, I'll just read it for you. Therefore, with each growth in complexity, more free energy is lost as a proportion of the energy system as a whole. Total energy of the resultant system is easy to formalize, and that's equation 2. And then we get equation as the system, and as the system becomes more complex, the ratio falls whilst the relationship increases. Oh, it's stuff. And then you go all the way down and you get to the final equation. You run to the final equations, and that is the final equation of free energy. I even made a video of it when I was making the presentation of this paper. It's called Information, Knowledge, Economics, and Technology. It's on YouTube. You can find it. We have an information package. It can be a basic particle. It can be a galaxy. It can be a human being. Here it is. It gets into a relationship. It's on its own. It is energy. There's energy to keep it structurally, and then there's energy that keeps it moving, that allows it to get into relationships. So if it gets into a relationship, there'll be less free energy. I mean, particles are free. Atoms are less free than particles. And atoms are more free than molecules. Understand? Because it's more complex. We are less free than a particle. We cannot go at the speed of light, and we're very fragile. We are the most complex thing we know in the universe. We live up to 100 years. Planets have been around for billions of years. Stars, because we are complex. And we have less free, even though it satisfies us, our relationships. But our relationships are such, we are less free. But we think we are more free because we have a mind. More energy has gone to keep us together, so we have less free energy. So I hope you understand that. That's all it is. I mean, people say, there's nothing to it. That's how everything works. That's why they try to give it to Lee Smolin. I mean, think about it. Gravity. It's no more special than any other quantum phenomena. If I leave the Earth, there is a point where gravity has no effect on me. There's no relationship, or the relationship is less. But right now, there's a strong relation, and that energy is gravity. And the energy holding, let's say, basic particles together, like a proton would be gluons and quarks. It would be the gluons holding it, the quark. You understand? There's nothing mysterious about it. There's nothing mysterious about it. The only mysterious thing about this is that they wanted to give it to Lee Smolin because he's white and I'm black. But because they knew it to be accepted because it's coming from a white. So, oh no, let's make it. No, it's from me. That's it. It's that simple. All we're doing with all these things, we're finding out the energy relationships. That's all we're doing in physics. And then we call the energy volts, this, all sorts of names. But we're finding relationships that are tied with energy. There's nothing fancy, there's nothing mysterious. It's just the difficult work of getting to know the relationship properly. But that's how everything works in the universe. Thank you very much.